All right, we're back. We're on page 3 of Calc AB Notes 29. This is actually a Calc BC topic or a Calc 2 topic, improper integral. So if you're in BC, this could be and almost certainly will be somewhere on your AP exam. If you're in Calc AB, this is for after the exam when we just kind of chip away at some stuff that you'll need to know for the future. So let's see what we're doing here. So we've already done a bunch of them where there was a discontinuity somewhere on the interval between A and B, maybe at A, maybe at B, maybe in the middle. These problems that we're about to do are where it's not a discontinuity, it's that you have an infinite bound, right? So maybe you have infinity here. If you have infinity there, what you're going to do is you're going to trick the fundamental theorem, right? You're going to go, instead of going from A to infinity, you'll do the limit. I'm going to end up using B because I think it's a better thing to do. But you'll take the limit as K approaches infinity, and K will be your upper bound. So first, you trick the fundamental theorem, you just use A and K. And then at the end, when you've got some quantity there, some expression, then you take the limit. So we'll be doing that. Or you can have an infinite lower bound. So your problem here, you're going to take the limit as K approaches negative infinity, but I'll be using A. And then you go from there. I think that doing the problems is the best way to really see this in action. So let's do some problems. So here we go. So upper bound is an issue. And it's the only issue, thank goodness. So we're going to say the limit, the upper bound, I'm going to say that B goes to infinity, 0 to B of e to the negative x dx. All right, let's do this. So negative e to the negative x, 0 to B. Fundamental theorem, as B approaches infinity of, so it's negative e to the negative b. So you might find it convenient. In fact, I'm going to do this. I'm going to write it as negative 1 over e to the b, because it makes it way more obvious what's happening there. And then minus negative e to the 0, so just negative 1. Okay, so if b is approaching infinity, e to the b is approaching infinity, so you have 1 over infinity. That's going to be 0. So overall, we're going to get 1 for this. And that is going to be our answer to that problem. So that one went kind of quickly because it was pretty easy to find an integral, an antiderivative, whatever word I'm looking for. Let's check it. So integral. So again, the calculator knows what you're doing. So you should use the template. It's easier for me to type exp. That's just e, the exponential function. E to the negative x is the variable, 0 to mash the pi key a couple times, and you will get infinity. But we do it and we get 1. So calculator is really good at these problems, so you should always be checking your answers. We haven't gotten to the point where the calculator can do the problem without us yet, but when we do, I don't know what we'll do. All right, what's the problem here? So if you look at the denominator, x equals 1 actually is a problem, but we're only going from 2 to infinity, so really our only problem is this infinity. So let's deal with that by doing the limit. It's the upper bound again, so as b approaches infinity, 2 to b of, I'm going to make it x minus 1 to the negative 2 and dx. Find an antiderivative. Got to write the limit as b approaches infinity. So that's going to be negative 1 over x to the negative first plus 1 times the reciprocal. So you get negative 1, quantity x minus 1 to the negative 1, but I choose to rewrite it because I think it makes it look clearer what's going on. Do this. Limit as b approaches infinity of negative 1 over b minus 1. B is going to infinity. If b was going to 1, we'd have a problem. We don't have a problem there. And then minus, when you plug in 2, you get negative 1 over positive 1. So negative 1. So far, so good. Take the limit, and if b approaches infinity, 1 over b minus 1 is just basically 1 over infinity, so that's 0. So we get positive 1 again. That's interesting. Let's check that. It's weird that you would get the same answer on 2 problems in a row. I mean, it's not that weird, but like, why would the person who wrote these notes do that? So we're doing the integral 1 over x minus 1 squared. X goes from 2 to infinity. And we get 1. All right, so we got it. Nice. Good job, us. Let's go back. I feel like we can knock out some more of these. If the iPad decides to come back, which it isn't. All right, hold on. Let me stop the share, get a big version of my face. Share, screen share. Oh, we're back. Okay. Disaster averted. Here we go. This problem would cause us a problem if 0 was in the domain of the bounds, but it's not. We're going negative infinity to -1. 0 is not in there, thankfully. So instead, we can just rewrite it. So it's the lower bound this time that's a problem. So I'm going to write it as the limit as a approaches negative infinity of the integral from a to -1 of, so this one, because I recognize it, I'm going to leave as dx over x, because that's very famous, right? That's natural log of the absolute value of x. You need that absolute value on this problem. The limit as a approaches negative infinity, natural log of the absolute value of x from a to -1. So if you don't put the absolute value on this, I don't even know. Natural log of -1 doesn't exist. There's no way you're going to negative infinity. It's like domain issues everywhere, but it's supposed to be the absolute value, so we're good. All right, limit as a approaches negative infinity of fundamental theorem, natural log of, so the absolute value of -1 is 1, so I'm just going to write natural log of 1, and then minus the natural log of the absolute value of a. All right, so natural log of 1 is 0. The natural log of, so it's minus the natural log of basically infinity, but natural log goes to infinity as x goes to infinity, right? So this is going to be 0 minus infinity, so negative infinity. We didn't get a finite number, so we're going to say, therefore, the integral from negative infinity to -1 of dx over x diverges. And I'll put an exclamation point because I'm kind of excited about that. Let's check this one. Then let's see if we can get the iPad back. That was a harrowing experience last time. Integral of 1 over x, x is the variable, negative infinity to -1. Negative infinity, we got it. So diverges is what we say, right? Because we didn't get a finite number, so diverges. All right, let's go back, hopefully, to the iPad. Yeah, flawless, smooth transition that time. Okay, so this is part C. I'm going to stop here, come back in the next video and finish these off. This is part C. Here's part B, where the issue was the upper bound was infinite. Here is part A, where also the issue is that the upper bound was infinite. You deal with them basically the same way. You just got to like keep your head about you. Know that you're going to have to use limits. Your notation matters a ton when you do these. I'll be back in the next video and we will keep going. So I will see you then.